Hello, everyone. This is Rona from eMaint Enterprises, and thanks for joining us today for this month's Best Practices webinar. And let me just start by clarifying a little bit about our Best Practices webinar series. As you know, as a software provider, we offer quite a variety of web-based trainings and product demos, but our Best Practices webinar series is a little different. And we try to, excuse me, we try to focus not so much on software, hardware, or technical topics, but really more on maintenance strategies. So we invite various subject matter experts from throughout the industry and from a variety of industries to come and present to you. And I'm really pleased to present our speaker today, John Schultz, who's the co-founder of the Allied Reliability Group, who's going to be presenting today's topic. And I had the distinct pleasure of meeting John at the Fluke Roadshow, which was really a technical innovation roadshow. I think it was back in May. And John was one of our keynote speakers. And it was a really inspiring presentation. So I was really thrilled. And John agreed to come and do a presentation to all of our listeners today and to a broader audience and take time out of what I know is a very busy and late night travel schedule, so I really do appreciate it. So, hey John, thanks so much for joining us. And while I'm giving, we had quite a few registrants, so I want to give them a few minutes to all get logged in. And maybe you can tell us a little bit about today's topic, proactive workflow model, sustained relevance. I'm kind of intrigued and why you chose to present this, and you know why it's important, and why you chose this one for today.
Well, Rona, thanks for asking. Since my days at Eli Lilly and Company, the proactive workflow model has been one of the underpinnings of my entire approach and the company's entire approach to reliability improvement strategy. And the tagline of sustained relevance was that about 3 years ago, when I started hearing about this industrial Internet of Things, I started questioning myself whether or not the proactive workflow model would still be relevant in what is now emerging as the industrial Internet of Things. That story goes back actually about 7 years ago. I began to become extremely frustrated with the lack of innovation in the condition monitoring and reliability market. Because of that frustration, I actually started going out and partnering with different colleges and universities that were doing a lot of great grant applications and research and development in areas such as condition monitoring, wireless, mesh network, artificial intelligence. So I partnered with organizations like Clemson, University of Louisville, Texas A&M, Virginia Tech, University of South Carolina, and Tennessee. With some of them, it was deep partnerships. With other ones, it was kind of in an advisory status. And through that, I started getting exposure to things like smart grid technology at the University of Louisville that has led to motion amplification that's in the marketplace, and something called Intelligent River from Clemson University. And Intelligent River really started to begin to give me visions of the future of what device-to-device connectivity could be, and what has now kind of emerged as one of the underlying studies that helped with the whole industrial Internet of Things. So for the last 3 years, we've been evaluating and trying to contextualize what all is going on in the marketplace to our business model. And what I've found as I talk to other people in the maintenance and reliability community is the maintenance and reliability and asset management communities, many of the participants are actually struggling to figure out how the industrial Internet of Things is going to impact them and their business. So this presentation is very maintenance and reliability centric, and it is meant to basically help make the industrial Internet of Things more approachable for the maintenance and reliability community.
That's excellent. Thank you, John. And that's certainly a question we're often asked. How does this relate to me, right? How is the world? Well, excellent. Well, before I just turn things over to John, a couple of quick housekeeping items. We are recording today's session, and we'll be sharing the link to the recording with all of our listeners today, so you can view it on demand or share with your teams. But I do have your phones on mute to avoid background noise. But John has agreed to stay through the end of the hour and answer any of your questions, as many as time permits, at the end of the sessions. But please feel free to type them at any time into the questions feature in GoToWebinar, and then I'll read them to John at the end of his presentation. And let's see, John has also agreed to make available a PDF of his slides, and at the end of the session there'll be a little survey with a checkbox where you can indicate if you'd like to get a copy. All right, so I know you didn't come to hear me speak, so I'm going to be turning things over to John. Thank you.
So before I get into the base of the presentation, Rona asked me to introduce a little bit about myself and my background. I was a former reliability leader with Eli Lilly and Company back in the 1990s. I was fortunate enough to be Eli Lilly and Company's first reliability engineer, and got to go to a tremendous amount of training and benchmark against a lot of different sites. In the early 1990s, as many of you know, is when the Society of Maintenance and Reliability Professionals was founded, and I got the opportunity to go out and actually benchmark against some of the best startup maintenance reliability programs in the world. And the only reason why I say startup is because there was a lot of organizations that had silos of excellence, and we identified what those silos of excellence were in things like planning and scheduling, RCM, condition monitoring, root cause, MRO, and we would go out and actually benchmark against those facilities to understand where we stood, and more importantly, where we wanted to go. So today, we've actually benchmarked as allied across over 1,400 sites in 14 different industry verticals around the world. I have personally participated in the reliability improvement process in over 300 sites. We've been building out our integrated approach to asset reliability improvement, and you'll see that with the proactive workflow model. We have a very unique execution approach called Do, Teach, Find, that regardless of how our client wants to get to best practice, whether they're looking for an engineering services company to help them come in and fundamentally improve, or whether they're looking for somebody to come in, coach, train, and mentor them, or they're needing talent acquisition support to add team members to their team, we're there to provide them with a comprehensive and very robust and flexible solution. In October of last year, Allied Reliability actually merged with T.F. Hudgens. T.F. Hudgens is a reliability solutions company out of Houston, Texas, heavily embedded in the petrochemical oil and gas industry that's been around since 1947. And one of the most exciting things for me about the T.F. Hudgens merger is my new role as Executive Vice President of Reliability Solutions, where I get to go back to focusing 100% of my time where I'm passionate, which is growth and innovation. I'd like to start off the presentation talking a little bit about the difference between best practice performers and average performers. The next couple of slides is specific to the oil and gas and petrochemical industry, but as I suggested, we've got benchmark data for over 14 different industry verticals. This first slide shows you that petrochemical oil and gas best practice sites actually spend 50% less per year on maintenance than average performers. I'm not talking about bottom quartile or laggard performers. I'm talking about actually average performers. But one of the things that we know about best practice plants is that best practice plants have best practice behaviors, and those behaviors is what actually drives best practice results. So when you look at those best practice performers, they didn't get to 50% less maintenance costs by simply cutting maintenance costs. They got there by improving their processes and practices. And those best practice performers tend to score higher in every area, They score 35% higher in asset health management. They score higher in reliability engineering, preventative maintenance, predictive maintenance, MRO, planning and scheduling, operator care. They also, when you start looking at condition monitoring, they are actually applying the technologies to a much higher percentage of their asset base. This next slide seems to be taking a little bit to load. There we go. Sorry about that. So they are actually applying vibration analysis as an example of 47% more assets than average performers. And on the other side of the equation, you see that they're actually applying time-based PMs to a smaller percentage of their asset base. The next slide that I'm going to introduce is actually what we call the proactive workflow model. And as I'd mentioned, this proactive workflow model has been around since the early 90s and was actually originally developed as a mental model roadmap for reliability improvement at Eli Lilly and Company, along with my executive sponsor, Bob Cole, who is Executive Director of Manufacturing, and Ron Reimer at Lilly, and I came up with what we call the proactive workflow model, and it's evolved over time, but many of the elements are still what they were in the early 90s, interestingly enough. We're going to break the proactive workflow model down today into three fundamental areas that we're going to predominantly talk about. We're going to talk about foundational elements, we're going to talk about work management, and we're going to talk about reliability engineering. But before we get into that, when we start thinking about IIoT and mental models, we have been evaluating over the last 3 years literally dozens of IIoT mental models that different organizations in that space actually have. And none of them really resonated with us and fit our contextualization as much as the one from the people at PTC. PTC has a very simple contextual model. It has 5 steps. Step 1 is source. This is where you're tying into all of your data sources, whether those data sources be coming out of Amazon Web Services Cloud, whether they're coming out of SAP HANA, whether they be coming out of GE Predix, whether they be coming out of Microsoft Azure, or whether it be part of your CAD or product lifecycle management process. So the first thing they do is they actually pull together all the data. The second piece that they do after they source the data is they contextualize that data. And what that means is that's where you're starting to build up that digital twin. That's where you're starting to actually talk about where that and what that asset is, that data is related to, and what that asset is actually supposed to perform. Now, the interesting thing is this order of source versus contextualize. This view of the model here is much more of a data scientist view. From a data science perspective, you tend to start with all the data that is available and then figure out what the data tells you. We as maintenance and reliability professionals tend to start with contextualize. We start with an asset hierarchy. We start with all the attributes. We start with all the failure modes and failure effects and what inspections can we do. And then once we get down to that what inspection, that's where we start saying, okay, where can I source this data? So from a maintenance and reliability professional perspective, we tend to start with contextualize and then move to source. So that's as you start looking at what does the IIoT journey mean to me, that is one of the important skill sets that we as maintenance and reliability professionals need to understand and begin to build is this concept of data science and utilizing data that isn't necessarily data, that's usually in another silo, that isn't data that we normally try to leverage. After contextualize, you get into synthesize. This is where you're starting to actually apply artificial intelligence and you're getting into machine learning. After synthesize, you start getting into orchestrate. Now that I've actually done machine learning algorithms, I've actually starting to get to where I have recommendations. I need to do something about it. I need to act upon this recommendation. This is where I start tying that data back and that information back into my work management system. And then finally, engage. And this is where you actually, in the engagement piece in the IIoT space, they start talking a lot about augmented reality. They start talking about wearables and mobility solutions. How do I actually execute the work in the field? How do I engage with the computer maintenance management system? How do I engage with my overall IIoT model? So what I'll try to do over the course of this presentation is tie the source, contextualize, synthesize, orchestrate, and engage concept back to the proactive workflow model as we start going through some of the discrete elements. But before we do that, Rona, if you would go ahead and launch the first polling question.
I can do that. Okay. So John just wants to get an idea of our listeners today and where are you in the IIoT space? Have you identified or completed an IIoT pilot? And just let us know. And again, these are only, there's no wrong answers here. We'll only be sharing results in aggregate to try to give John a feel, and even of all of our listeners, where are we in this continuum? All right, so I see we have about 3/4 of the votes in. I'll leave it open for a few more seconds and then share the results. Okay, let me go ahead and share results. Well, interesting, John, we're at only 4% say yes, they have an IIoT pilot. 81% say no, and 15% say don't know. So kind of resounding, what is that now? 96% aren't currently identifying. I've started.
And this is one of the reasons, it's interesting that is the results, Rona, because this is one of the interesting things that I found. I find that the maintenance and reliability community is largely confused by the IIoT because it has become more of an IT discussion than an OT discussion. And what I'm going to try to do with going back to a model that maintenance and reliability professionals can relate to, the proactive workflow model, I'm going to try to bridge some of those gaps for the listeners, and hopefully we're successful in doing that. So the first thing that we start thinking about with regards to the proactive workflow model is what we refer to as foundational elements. The foundational elements consist of building an asset catalog, performing asset criticality analysis, doing a failure modes analysis, and also then from that failure modes analysis, building an equipment maintenance plan. What we have found in benchmarking over 1,400 facilities is when we initially go in there, over 60% of the sites that we benchmarked do not have an actionable asset catalog. They do not have a hierarchy that is anywhere near compliant with the ISO 14224 standard. What that often translates into is that many of the people that we're benchmarking, many of the sites that we're benchmarking, don't even know what they own. Over 70% of the sites have insufficient asset criticality. They basically have either critical, not critical, or only 3 levels of criticality, and they end up with a high percentage of their assets being undistinguishable from an asset criticality from the others. So it makes, they tend to be very good at going in and trying to put advanced reliability practices in place in their top 10 to 20% most critical assets, but they struggle to get to best practice and see that lower maintenance cost replacement asset value and that higher OEE because they don't know what to attack next. Because again, they don't have enough granularity in their asset criticality analysis. Over 80% of the sites that we've benchmarked have not mapped their components to failure modes and the failure modes to inspections. So oftentimes what that means is they have a bloated preventative maintenance program, and they are not even exactly sure why they are performing the tasks that they are performing. And over 90% have not optimized their equipment maintenance plans, which means oftentimes they're performing the wrong task at the wrong frequencies with little or no execution standards. So they're unable to actually give their people what they need in order to consistently execute work. They'll have a PM task that the title of the PM is inspect pump. Step 1, inspect pump. Step 2, end of PM. And it is amazing how many organizations that we go into that is all the details that their preventative maintenance program actually goes into. Uh-oh. I say uh-oh because my slide's not advancing, Rona.
Well, John, why don't you continue talking through this?
No, it finally advanced.
Okay.
It is actually in the process of advancing right now, and actually the next one is the next polling question.
Okay, let's go ahead and launch the poll. All right. So John is asking, how mature is your organization in these very important fundamental elements? Okay, IIoT is all the rage, but back to the basics. Where would you characterize your where your organization is? Perhaps you have no formal program, you're doing some experimenting. Would you characterize it as enlightened, good practice, or best practice? Okay, and again, no wrong answers, just want to get your personal assessment of where you think your organization is regarding these practices. It's always interesting to, gives you a chance to benchmark against each other and see that you're not alone. All right, again, we have about 70% of the people voting. Leave it open a few more seconds. Cool. Let me go ahead and share the results. So, John, 23%, or nearly a third, are saying they don't have a program. 30% say they're in the experimentation phase. 23%, or about, I guess, I'm sorry, not a third, but another quarter, say they're in the enlightened phase. And then 22% say good practice, but only 1% of our listeners would characterize their program as best practice. And perhaps that's why they're joining us today, to pick up a few more pointers. So,
no, that's not inconsistent at all with what we see from our benchmarking data across over 1,400 facilities. And now when we try to tie this concept of foundational elements and what we just went through as to where you are on your particular journey is having no program or experimental or enlightened and not necessarily having the asset hierarchy, the asset criticality, the failure modes, the mapping, or the equipment maintenance plans that you should. This starts to correlate when you're starting to look at trying to do an IIoT pilot in the maintenance and reliability space, is if you don't even know what assets you own, what is it exactly that you plan on digitizing to put into your digital twin? A digital twin is basically a digital replica of your physical assets, processes, and systems, which then allows you to do things like simulation modeling to offline start identifying based on the data that's coming in through applying machine learning and artificial intelligence. How far are you from failure? How much useful life do you have? And actually starting to get into prognostics. But if you don't even have an asset hierarchy, let alone all of your asset attributes, all of your maintenance manuals, understanding of your failure modes analysis, what is it that you're planning on digitizing to actually become your digital twin? So when you don't, in the absence of that, that's the reason why I believe that only 4% of the listeners said that they actually have an active IIoT pilot, is because oftentimes you get into organizations and people are wanting to figure out, where do we want to apply IIoT, and they immediately disqualify maintenance and reliability simply because the foundational elements are not there. The next question is, if you don't understand your failure modes, what rules-based logic are you going to apply to machine learning? And then the last question there is, can data science alone turn grossly incomplete information and often the wrong data into actionable work? And I think we each know that the answer to all of those questions is no. Data science cannot take grossly incomplete information, the wrong data, and actually turn it into actionable work. If it does, it's highly probable it could turn it into the wrong action. The next area that we're going to explore is work execution management. And with work execution management, that's where you go in and you try to plan, schedule, and execute your work. Today, 97% of the assets that have any condition monitoring strategy across the sites that we've benchmarked are actually doing route-based data collection. However, I will say this, the wireless revolution is here and it is real, and it is getting stronger and more cost-effective every day. 5 years ago, if you wanted to do inline condition monitoring, permanently install an accelerometer, you were looking at over $3,500 per point. We have seen over the last 5 years that $3,500 dropped to $2,500, $1,800, $1,200, $800, $600, $300, and there are companies that are doing some innovations today that will likely drop it well under $100 per point over the next few months. And so the wireless revolution is upon us. So assets that we never thought that we could install a permanently mounted sensor on to collect condition monitoring data. And condition monitoring data above and beyond just purely vibration is rapidly approaching us. And many will say that it's already here. And what I would say is that the technology is here. Most organizational readiness to leverage that technology is what is still lagging. And they don't have the leadership and change management support to actually move it forward. So what I will say is, if you have the foundation correct, both supervised and unsupervised machine learning have amazing promise to improve the effectiveness of our ability to identify and predict failure. Now, does this mean that it is going to completely remove the role of the analyst? No, but what it is going to do is it's going to free up more of the analyst's time, and it's going to allow the analyst to actually manage more components and spend less time doing physical data collection in the field, more time doing advanced analytics, and working as a change agent to help the organization move the work through the process and do things like root cause analysis to make sure that the problem never comes back. And digital twin and augmented reality are slated to really improve efficiency. When you start doing time motion studies and you start recognizing that best practice maintenance organizations today have wrench times of 50 to 55%, and the average is closer to 28%, you begin to realize that there are a lot of inefficiencies built into the field due to the lack of information at the point of turning the wrench. What digital twin and augmented reality are slated to do is close that gap so that the people that are performing the work have all the information and the tools they need when they need it to perform the work. And so in 5 years, it's my prediction that average is going to start creeping up much closer to what best practice looks like, and best practice numbers will absolutely be numbers that previously we thought were unattainable. with regards to wrench times and time motion studies. Right now I'm trying to advance to this next slide. For some reason, my system locks up periodically. All right, so the next area that we're going to explore will be reliability engineering. And I'm breaking reliability engineering, which is really where continuous improvement lives, into legacy tools for reliability engineering, things that we as maintenance reliability professionals are used to applying, and then some new skills that reliability engineers are likely going to have to be building over the next 5 years. Some of those legacy tools include things like reliability-centered maintenance analysis, root cause analysis, and within root cause, I would also throw some of the advanced diagnostic stuff, such as modal, ODS, and motion amplification, just as examples of advanced diagnostic techniques that can be used to actually get to root cause. And we also, as reliability professionals, are used to applying basic reliability engineering statistics, such as Weibull analysis, Crow-Amsa plots, etc. Some new skills that we're going to have to develop over the next 5 years as maintenance reliability professionals, if you don't already have them, is this whole concept of data science, advanced statistics, really being able to apply algorithms to the data to let the data speak for itself. Machine learning and artificial intelligence, those are 3 skill sets that we as maintenance and reliability professionals are going to have to become much more proficient in over the next 5 years as the industrial Internet of Things, Industry 4.0, smart factory, all the things you're hearing about today begin to take hold. And so this next slide focuses on 6 core skill sets that we are actually, as an organization, recognizing that if you do not have these 6 core skill sets, and again, I'm not saying these are the only skill sets, but if you do not have these 6 core skill sets, you will not have a successful deployment of IIoT. First and foremost is leadership. You need governance, you need solid definition, and you need to define upfront what success is. One of the other mental models that I picked up on from my friends at PTC is their motto is think big, because the industrial Internet of Things allows us to do a lot of things that we never thought we could do before. Start small, and then once you've defined success and achieved success, expand fast so that you don't lose momentum. I cannot understate the importance of upfront having good governance, definition of scope, and success. If you do not define what success is upfront, it is unlikely that when people look back that you will have achieved your goals. So it's just like any other Six Sigma project, you need to have a good charter and you need to have leadership buy-in and support. The second one is don't wait too late to involve and start having the conversation about cybersecurity. I think the single biggest threat to IIoT not taking off the way that we would like for it to is people's fundamental fears of cybersecurity. So you need to very early on understand what level of cybersecurity is going to be necessary and how you're going to achieve those goals. The next one is concept of failure mode mapping and test and measurement optimization. In reliability-centered maintenance, step 6 is going through the decision tree of, now that I've identified a failure mode, is there an on-condition monitoring task that is technically feasible and worth doing? First, once you start eliminating data silos and you start bringing in all of your ERP data, your condition monitoring data, your data historian from your OSI soft or any other data historian that you may have, now all of a sudden the failure modes that you can identify from an asset performance management standpoint are greatly expanded. Second, the cost of these sensors is coming way down. So now it's not just about whether or not is an on-condition monitoring task technically feasible and worth doing. It's about expanding your thinking about what is on-condition monitoring. Then it's about, is this something that I am going to do route-based, or I'm going to permanently mount a sensor? If I'm going to permanently mount a sensor, how frequently do I need to collect data? What quality and what resolution does that data need to be at? So there's just additional considerations when it comes to failure modes mapping and making sure that I optimize that test and measurement. Project management skills. These IIoT implementations are projects that need to be well managed, and you need to make sure that you have all your data flowing from all your sources and it's validated and it's hooked to your model. Machine learning, data science, artificial intelligence, and the final one, which also cannot be understated, is visualization. One of the biggest promises that I see with some of the technologies that are out there today, some of the technology stacks, I guess I should say, is the ability to scorecard, the ability to do what they call mashups of being able to put very visual graphics in front of people so that they can relate to the data, as opposed to just seeing rows and rows and rows of data, lots and lots of squiggly lines, being able to actually put that into a visualization medium that helps everybody from senior leadership down to the operator on the floor understand what that data means. Customizing the data view for the viewer. And so visualization skills is another core skill set that if you mess up the visualization, you will not get the optimal return from your IoT project. And that leads us to our third and I believe final polling question, Rona.
Yes. So John just shared with you 6 core skill sets that he's identified that are really going to be important in the world of the future, and is asking just how many of these skill sets does your team currently have? These are rather different than the skill sets generally within a maintenance and reliability organization that are focused on. So let us know, are there none, 1, 2, 3, 4? I think he mentioned 6, but I'm only given 5 choices here. So tell us which best applies to your organization.
So again, those are leadership, cyber, failure mode mapping and test measurement optimization, project management, machine learning, data science, artificial intelligence, and finally visualization.
Very good. We'll give you a few more minutes, or a few more seconds here to digest that and weigh in. And, all right, let's see what we have here. John, so about 15% of our listeners are saying they don't feel they have any of the core skill sets. 27% say 1, 30% 2. So over half are in the 1 or 2. 16% say 3, and 13% have 4 or more. All right. How consistent with what you were expecting?
Yeah, again, not inconsistent with what we're seeing from facilities that we go in and benchmark and customers that we're talking to about their IIoT journey today. So the next slide starts to take that proactive workflow model and basically breaks it down into categorization of work. Some of the types of predictive inspections that we're talking about when we start talking about predictive inspections representing 15% of the total labor man hours and 35% of the corrective work that gets done as a result of that inspection. PM inspections, and then some strategic KPIs. I won't dwell on this slide too long, but one of the things I do want to talk about is really what we're talking about largely in the maintenance reliability community also is in that predictive inspections with IIoT. A lot of that data that we've been dependent on running a route and struggling to get better than 75 to 80% route compliance will be continuous monitoring data or semi-continuous monitoring data from a low-cost but high-quality sensor physically in the field. So it's going to be interesting to see how these percentages of work migrate over time. As well as, do we have to recategorize it and stop looking at it as the percentage of workflow hours, but the percentage of actual work activities that get done? But as we start looking at some of the strategic KPIs, again, 15% of your total labor hours in a best practice plant today is spent performing PM work, 15% performing the PDM inspection itself, 80% of the work is considered proactive and planned, 90% schedule compliance, and 90% of the assets are defect-free. And so what we mean by 90% asset health is that you've taken the assets that are part of your reliability program, you've mapped every one of the failure modes to an inspection, you've mapped the inspection to acceptance criteria, and based on your acceptance criteria, 90% of your assets are defect-free. That is what best practice plants are achieving today, and we've got several examples of those. This next slide begins to just give you a feel again for first, second, third, and fourth quartile performers. Where do they fall? And this is not just oil and gas. This is actually the average across all industry verticals. Where do they fall today when it comes to maintenance costs or replacement asset value? MRO stores value per replacement asset value, planned work, scheduled work, work from PDM and results, work from PM and results, what their true OEE is, and what this measure called reliability index is, which is actually a derivative of Paul Behringer's reliability process plots. And if you start looking at the first quartile versus the top end of the second or the low end of the third quartile, you can begin to see the tremendous differences between top quartile performers and even average performers in each and every one of those KPIs. This next slide is just a collection of different case studies of what they actually seen by going through a reliability improvement journey. No one site achieved all of these results. This is just a accumulation of different case studies. So one site saw a 28% reduction in their annual maintenance spend in their first 3 years. One site saw a 20% increase in their OEE, 30% reduction in spare parts inventory, a 9% increase in their OEE in 4 years. While that might not sound significant, that particular organization was taking their OEE from the mid-80s to the 90% range, and squeezing out that last little bit of OEE was substantial. They also did that across a number of facilities, and they were actually able to find a couple of hidden plants through that exercise. 1.4% improvement in maintenance cost replacement asset value. One site actually doubled their actual production throughput over 3 years. And as I mentioned, another organization across 20 facilities was able to basically add an additional facility at variable cost through the reliability improvement initiatives, meaning that each site saw a 5% increase in overall throughput, so the equivalent over the reliability improvement period of actually adding that mystical hidden plant that so many people in the reliability community talk about.
John, just before you get to your next slide, you do reference OEE, and one of our listeners asked, could you define that and how you measure it?
Yeah, so OEE actually stands for Overall Equipment Effectiveness. And overall equipment effectiveness is the multiple of 3 variables. The first variable is what is your availability. So there are 8,760 hours in a year. How many of those hours are you actually running? The second variable that you multiply that by is what percentage of either your maximum demonstrated throughput capacity or your design capacity are you actually running at when you're running? And the third one is what percentage of the product coming off of your line is actually first pass, first quality yield. So if you're running 90% of the time at 90% rate with a 90% first pass, first quality yield, your OEE, your overall equipment effectiveness, is 0.9 times 0.9 times 0.9, or approximately 72%, which means you have a hidden plant capacity of 28%. And most organizations that I go into, at least, and we benchmark initially, wishes they had 90% availability at 90% rate and 90% first quality yield. So there's lots of opportunities to go out and actually improve overall throughput through the Reliability Improvement Initiative. This next slide is a slide that is a benchmark study that was originally done by MIT that actually looked at the rollout of several technology improvement initiatives across organizations, many of which were actually ERPs in the 1990s at 2000 through about 2007. And what they found was that organizations that just simply implemented technology for technology's sake without impacting or improving upon their business process or their cultural maturity actually saw a negative return on investment for that technology investment. Organizations that did not enable their business processes and cultural maturity improvements with technology saw an improvement of 27%. But those organizations that were actually able to use technology as a lever to improve their business processes and cultural maturity actually saw nearly 3x the return. So innovation alone does not drive ROI. And that's part of the reason why any innovation goes through the Gartner hype cycle. And right now, IoT, artificial intelligence, machine learning, augmented reality are all near the top of the hype cycle. And what you're going to see over the next few years is this, what they call the trough of disillusionment, where the hype starts to come down because people actually go out and try to scale this beyond a pilot. If you do not have the foundational elements in place, if you do not have the core skills in place, if you do not have the leadership and cultural maturity in place, technology and innovation alone, on average, has a negative return on investment. And so the caption at the bottom of this is something that this year, whenever I keynoted the MFPT conference, is something that came to me during that conference, and that is that the culture that you create is more important than the measurements that you take. Because if you cannot figure out how to act upon the data and information, you're just going to be absolutely overloaded with information that you're still not acting upon, and you're going to be throwing money at technology. So it's really important that you establish those other elements. And with that, I will open it up to Rona. I think we have, what, about 15 minutes left?
Yeah, well, at least 10 or 12 by my watch, but thank you, John. We've had quite a few questions come in, including, again, if you'd like to get a copy, several people have asked for a copy of the slides, and John there'll be a little survey at the end of the presentation where you can request a copy, and when John gets back from his travels later this week, he'll be happy to share them. But John, can you explain the difference? You talked about planned work and also scheduled work when you were talking about compliance and the best practice KPI measurements. Can you explain the difference between those two, planned versus scheduled?
Yeah, so planned work is where you actually put together a detailed job plan. So step-by-step instructions of what needs to be performed, what labor resources need to be assigned, what tools need to be assigned, what cautions you may have, and what parts need to be part of the job so that it can actually be kitted. And so the planning process is actually putting together a formal job plan for execution. Once I have a planned backlog, I can now schedule that work. And schedule compliance is what percentage of the work that was on the schedule actually got executed and completed to the schedule. So best practice plans have approximately 80% of their work is planned, and they have 90% of their work that is scheduled with 90% schedule compliance.
Excellent. Jen, when you shared the slide about best practices plans, we had a listener asking, for those that really are in that top quartile, how did they get to do this great work? Is it done by one person? Is there a team? Maybe you can describe a little more about the characteristics of the teams who are in that top quartile from what you've seen.
Well, it's interesting because one of the things that I'll also say is across 14 different industry verticals, as we look at benchmarking across all of the different elements of best practice, no industry vertical has a monopoly on best practices. So many industry verticals only look at, well, you know, if I'm in power generation, I'm only interested in best practices in power. Well, if you do that, as I'm looking at my data set right now, out of the 35 elements of best practice, power generation only has best practice in 4 of those 35. You would need to look outside of power generation if you actually want to achieve best practice. So that, and it's not just, you know, and that's industry vertical by industry vertical. No industry vertical has demonstrated best practice in more than 7 of those 35 elements across our benchmarking data. The second thing that I would say is that organizations that are able to achieve these results have strong executive sponsorship. You have some companies are fortunate enough to have the corporate culture to have that executive sponsorship at a very high level. Some organizations may only have that executive sponsorship at a plant, and you may have an enlightened plant manager, maintenance manager, engineering manager that just is absolutely dedicated to the initiative. No one person can ever achieve reliability on their own. You have to engage the workforce. And that is why, you know, the old saying goes, the hard stuff is the soft stuff. For every the technical elements of reliability improvement, many of which are not all that complex, they just require a tremendous amount of discipline and organizational engagement. And if you can't capture the hearts and minds of the people that are on the floor and convince them that this is going to make their lives better, the probability of, regardless of how much technology you throw at it, of actually seeing best practice results is near zero. You have to figure out how to engage the workforce and get them excited and make this about their journey, not just being a reliability engineer and thinking that you can will your way to best practice.
Very good. And, you know, on the note of different verticals, we had a listener ask, because you referenced some ISO standards, and he's wondering, are there similar ISO standards if you're in more of a facilities management, let's say commercial office building maintenance? So maybe you can you know, tell our listeners a little bit about where they can go to find out these different standards that exist.
Yeah, there is a complete, and I don't know the numbers off of the top of my head, but there is a complete list of ISO standards. I would probably start with the ISO 55000 series standards, which really focus a lot on infrastructure. And with all of the standards, it's also about contextualizing it to your context. I don't necessarily, you know, Some of the standards are absolutely, will fit your operating context perfectly. Some of the standards you may have to contextualize to your use case. We deal a lot with facilities management companies that are actually doing commercial real estate management. I'd be more than happy if, since my email address is on there, to take that conversation offline and provide a little bit more insight with regards to specific standards around facilities. I just don't happen to have them off the top of my head.
Cool. John, when you mentioned the foundational elements, having your catalog, your criticality, FMEA, and your maintenance plans, maybe, since our listeners are in so many different points in this continuum, tell us about, do you feel you have to have mastered one before you move on to the next, or are you really working on a lot of these, shoring up these different elements concurrently? Can you shed any light on that to help, maybe some of our listeners know where to go next?
Well, first of all, I would definitely say that they're sequential for a reason. If you don't know what you own, it's really hard to do asset criticality on an asset list that doesn't exist. If you don't know what's critical and where to start, it's oftentimes difficult to prioritize, to do the failure modes analysis. Now, what I will say is that there are different ways, and depending on your business goals and objectives, some organizations will take their entire facility and complete step one of asset catalog and walk down, and then systematically work to the step two of asset criticality, and then failure modes mapping, and then EMP. Most organizations don't have the luxury of being able to do that. And so what they do is they actually do a systems criticality analysis up front, and they use that to prioritize and basically say, based on our business goals and objectives, here's where our bottleneck is, here's where we're spending the money, here's where we make money. We're going to start by getting the foundational elements right on our most critical systems and processes first, and then move sequentially through the plant and allow the reliability improvement initiative and savings from those early success stories to fund doing other systems. So while they are sequential, you don't necessarily as an organization have to say, I'm going to take this entire facility and perform asset walkdown before I could possibly attack asset criticality or failure modes mapping. You can actually prioritize it within your own plant before you move through those steps.
Excellent. And does the same hold true for the introduction of predictive technologies? Because we're so often asked that, when is the right time to get started?
It's funny because depending on your DNA and how you're wired, you can look at this one of two ways, and I've actually seen both be successful. I've had many organizations, first of all, I need to get through the foundational elements and have leadership sponsorship before anything is going to be fundamentally successful. But then when it comes to some organizations want to get really, really good at planning and scheduling so that they can plan and schedule the work that's coming out of condition monitoring before they ever move on to condition monitoring. The challenge with that is in that situation, you end up with a high percentage of your work being very close on the P to F curve to F, because you're using visual observation, you're using heat to the touch, you're using your sight, you're using your five senses and preventative maintenance to try to drive what your planner is working on. And then your planner can become the most reactive person in the entire organization. He becomes an expediter and coordinator. And so too often people are looking for a silver bullet with regards to, if I just implement this, I'll get to best practice. Unfortunately, best practice doesn't work that way. But what I will say is that what I'm a big fan of is, again, once I've completed my asset criticality and I've identified my most critical assets, putting those 10 to 20% most critical assets on condition monitoring route while I work through the kinks in planning and scheduling. As soon as I get to the point that I have a high degree of asset health on my most critical assets, and I've proven that for the work that I'm putting on schedule, I can get high schedule compliance, and I've proven that my workforce is effective at eliminating those defects, add more assets. Where do I get those assets? I go back to my asset criticality analysis and I add another chunk of assets. And I do the same thing. Now those are part of my predictive maintenance program. I prove that I can actually get those assets healthy. I prove that I can actually execute the work that's on the schedule. I prove that I have the craft skills that I need. And then I add the next chunk of assets until eventually I get down to the assets that have such a low asset criticality that we've decided to just have a run to failure maintenance strategy.
Right, and it's all connected. Well, thank you so much, John. And thanks again to our listeners. We are at the top of the hour. I want to be respectful of John and everyone's time, so we're going to be closing this, but please don't let the dialogue end here. John is obviously a wealth of knowledge and wisdom and experience. So there'll be a brief survey at the end. Let us know what other topics can we bring to you from speakers like John with this kind of knowledge. What's on your mind? How can we help you? Please indicate if you'd like John to send you a copy of the slides, and we'll do that as well. So thanks again, John. I really appreciate it. I've learned a lot. Thank you on behalf of our listeners, and we'll see you all the next time. Take care.